Okay, so let's solve this example. Let's solve our example just to have it, the full answer to this example we have solved through the quiz. And this is the equation dy on dx plus y is equal to 3 times x. So the integrating factor is equal to e to the integral of 1 dx, right? Because the coefficient of y is just a 1, and this is equal to the integral of dx, which is just ex, e to dx. So the integrating factor is e to dx. Then we multiply both sides of the equation, and we know that this will be just the derivative of mu times y. And we can check it. This will be u times y prime, which is this times this, times u prime times y, right? And then we can integrate both sides, and in this case, we have this one. And what is the integrating factor? E to the x, right? And we're left on the left side with mu times y. And on the right side, mu and mu. Okay, I'm going to replace in a moment. And this is with respect to x, of course. And mu is our integrating factor, which happens to be equal to e to the x. So here we have e to the x times y equal to the integral of e to the x times e to the 3x, which is equal to e to the 4x dx. And we have already solved that. And the integral of e to the 4x is equal to what? Because I did it wrong. 1/4 times e to the 4x plus c, right? And then we solve for y. And we have 1/4 e to the 4x divided by e to the x, or what is the same? 3x. E to the 4x minus x, which is equal to the e3x plus c e to the negative x. And this is the solution. Is that clear?
Profe, ¿podría subirle tantito para...? Porque
Yes,
un paso arriba.
you tell me.
Más.
There is no more.
Ahí está bien, profe. Como ahí el factor integrante era 1, integró esto, ¿verdad? Y obtuvo que era e a la x.
Exactly. The integral of dx is simply x, right?
Okay. I understand.
Okay. So let's work with another example. This time we will have, no, not this equation. Let's choose another one. X squared times y prime plus x times y is equal to 1. So first of all, we can see that this is not in the linear standard form, right? Because we have an x squared. Over here, we should have a 1. Now, how can we transform this into linear standard form? We can divide all of the equation. Okay, we divide all of the equation by x squared. In other words, every term will be divided by x squared. So in this case, we are left with y prime. Now we have a leading coefficient 1 plus x over x squared. And that will be equal to 1 over x and 1 divided by x squared. Now it is in the standard form. Is that clear? Okay, now once we have it, we have the linear standard form, we can find the gradient factor or mu. Mu will be equal to e to the integral of the coefficient of the y. This will be p of x. So we'll have the integral of 1 over x dx. And the integral of 1 over x is just, and as you have seen, we are not using the constant in the solution of this integral because we just need one solution for the integrating factor. We do not need a family of solutions. That's why I'm not writing the constant belonging to this integral, okay? And e to the log of x will be symbol x because e and the log will be canceled. So our mu is equal to x. This is our integrating factor. Now we multiply this equation, not this one, the standard form. We multiply both sides of the standard form by our integrating factor. And that will be 1 over x, I think. Is that correct?
Yes, I think so.
No hay que multiplicar el mu igual de otro lado.
Yes, you're right. And I have multiplied, right? On the right side, we have 1 over x squared. And 1 over x squared times x is equal to what?
Ah, ok, ya. Sí, no vi que la
There you are.
simplificó.
Okay?
Sí, sí.
Yeah, I have already simplified it. And now, just remember, this will be, that's our bit, this will be just x times y, the derivative. Is that true? And then we just integrate with respect to x, both sides. And in this case, on the left side, we are left with x times y. And the integral of 1 over x is equal to what?
Logaritmo de x.
Logaritmo natural.
Okay, and here we must write the constant, of course. And then we just solve for y. And then we will have something like 1 over x times log of x plus c over x. And there is our solution. Okay.
And we need to, teacher, we need to put the c over x, or we only put c?
Just remember the reasoning about this. If you have a constant and multiply that constant by a constant, for example, number 4, what is the result? Well, c can be any value. So if I ask you to give me what is the product of any value times 4, what is your answer?
Any value.
Any value. So you can replace a constant with any value times a constant with just a constant, and that will be the same in this case. But if you have something like this where x is a variable, you no longer can write something like this. Yeah, because x is not a constant, is a variable. So this expression depends on the variable. It can no longer be the value that you want. It depends on the variable. That's the reasoning. Is that clear?
Yeah, very clear.
Whenever you have a constant, which can have any value, times a variable, you left that expression like that. Okay?
Yeah, thank you.
So let's work with another example, a more difficult example. So let's suppose we have this equation. So this is clearly not written in standard form because we do not have a leading coefficient of 1. But once again, we know how to transform that coefficient into 1, just dividing all of the equation by cosine of x. Okay, so our P of t is now clearly identified. Yep.
¿Eso es tangente o me estoy equivocando?
No, you're right. This is tangent of x. Okay, but I'm going to leave it like that on purpose. Okay, and you will see it now. What is the integrating factor? Is the integral of the coefficient of y. And the coefficient is sine of x over cosine of x. So let's find this integral. And I want you to find this integral by hand. That means do not use any table, any integral table. Just to have a review of your integration techniques. And what can we do in this case? Maybe we can use substitution. If we say that du is equal to cosine of x, then du will be equal to what?
Menos C, ¿no, profe?
Negative sine of x, right? And as we have a sine of x, then sine of x dx sine of x dx is equal to du. So we'll have something like the integral of 1 over u du. We have done our substitution. And this is equal to negative log of u, but u is equal to cosine of x, right? And we have find the solution for the integral. So the integrating factor will be e to the negative log of cosine of x. And now we can use a property of the logs. That property says that this will be cosine of x to the negative 1. Okay? We're using this property of the logs. Whenever you have something like a times log of v, this will be log of v to the a. This coefficient moves as a power. Okay, that's what I'm using here. E to the negative 1 times log of cosine of x is e to the log of cosine of x to the negative 1. And that way we can cancel these two terms, these two functions, not terms, these two functions, and we are left for the integrating factor with, as you can see from here, cosine of x to the negative 1, which is simple 1 over cosine of x or secant of x, whatever you want. So we have our integrating factor. Now let's multiply both sides of our equation, and here's our equation, and here it is. dy dx, and let's multiply it, and we will have secant of x dy dx plus secant of x times tangent of x times y, and that will be equal to 1 over cosine. 1 over cosine of x times secant of x, but 1 over cosine of x is secant of x, so we will left with secant squared of x. And just remember, the left side will always be equals to what? The integrating factor times y. So we forget about all these expression, and we just write the integrating factor times y, and that will be equal to the integral of secant square of x dx, right? And the integral of secant square of x is a known integral. It is just, you remember the integral of secant square? If you do tangent of x, yeah. Okay, so here we have our solution. Y will be equal to tangent of x divided by secant of x, and maybe we can do a simplification over here, plus c over secant of x. And tangent of x is sine of x divided by cosine of x, and 1 over secant of x is just equal cosine of x. As I told you, 1 over secant of x is cosine of x, so we will have c times cosine of x, and our solution will be sine of x plus a constant times cosine of x. And ta-da! This is the solution for our given equation. And that's it for today. I'm going to finish the recording of this. So, any question?